Hey guys, welcome to day 33 of 100 Days of Code. It's Angela here, and today we're going to be learning about application programming interfaces, also known as APIs. What are we going to use it for? Well, we're going to learn this technology so that we're able to create an ISS tracker. So this is the International Space Station, and it floats high above in the sky and it circles Earth many times a day. Here's a video that's taken from the ISS, and you can see how glorious Earth looks in the eyes of the ISS. And what we're going to try to do is we're going to try and track where the ISS is currently at in the sky. And at the time point when the ISS is in the night sky, right above where we are, then we're going to send ourselves an email telling us to look up and spot the fast-moving ISS. Once you're ready, head over to the next lesson and we'll get started learning about APIs. First, let's take a look at what application programming interfaces are, and then we'll see how we can use them to start pulling in some data from the internet. So when you're browsing the web, you might have realized that there's a lot of websites out there that carry a whole bunch of data. For example, you could go on to Yahoo Weather and see next week's weather predictions for any city in the world. You could go onto Coinbase and see what is the current market value of various cryptocurrencies like Bitcoin and Ethereum. You could also go onto the NBA website and look at various stats about your favorite basketball players. Now, what if we wanted to use the data that they have? How can we tap into it and use it in our own programs? Well, that's where application programming interfaces come into play. They are a set of commands, functions, protocols, and objects that programmers can use to create software or interact with an external system. In the upcoming lessons, what we're going to be focusing on is this interacting with external systems. Namely, we're going to try and interact with various websites and pull live data from those websites. Essentially, the API is an interface, or rather a sort of barrier between your program and an external system. And what you're trying to do is you're trying to use the rules that the API has prescribed to make a request to the external system for some piece of data. And if you have structured your request according to all of the requirements that this external system has set out in their API, then they will respond to you appropriately and give you the data that you want. But if you don't follow the rules, then your request will be invalid and they will tell you to go away. So if we think about the websites we saw before, Yahoo Weather has a Yahoo Weather API, which you can tap into using your programs or apps and get things like 10-day forecast, wind, atmosphere, astronomy conditions, and Coinbase has their own API, which lets you tap into the current live prices of various cryptocurrencies. And of course, the NBA also has an API for you to be able to get various information that you're interested in on leagues, teams, players, games, and a whole bunch more. So essentially, you can imagine these websites as the sort of restaurant, right? And the data that powers these websites as the kitchen behind the scenes. We can't really go to a restaurant as a member of the public and just go in to the kitchen and start raiding their cupboards. You can't, imagine going to your favorite Japanese restaurant and heading straight into the kitchen for some of your favorite Kewpie mayonnaise. That's not really appropriate. In a restaurant, we have a menu, and this menu is kind of like the interface between you and the restaurant. It's the thing that tells you what you can order and what you can't. So maybe you can get a cake, a sandwich, or a tea from the restaurant, but you can't just go into the kitchen and demand whatever it is that you want. Essentially, an API is exactly that. It's the menu. It's all of the things that you can do to interact with an external system, such as a website that carries data, like Yahoo Weather or the NBA website. In the coming lessons, we're going to be looking at how we can read the documentation for the API and interact with them to be able to pull pieces of data that we want in the moment that we want it. So for all of that and more, I'll see you on the next lesson. Now, one of the most important aspects of an API is the API endpoint. And you can imagine that as a location, right? So we said that if we want to get data from a particular external service, then we need to know what location that data is stored. So for example, if you wanted to get money out of a bank, then you need to know where that bank is and what is its address. And that, when it comes to API lingo, is called the API endpoint. And that's usually just a URL. So for example, if you wanted to get crypto data, you might use api.coinbase.com. This is the location where the Coinbase data can be found. Now, in addition to knowing the API endpoint, you also have to make a request over the internet. This API request is kind of similar to going to the bank and trying to get some money out, so trying to withdraw some data from their vault. As you can imagine, the world would be completely chaotic if everybody was allowed to just go into a bank and take out the amount of money they need without any sort of checks and balances. So that's why in the bank you have a bank teller. So somebody who is there to ask you, can I help you? What do you want? And to prevent you from going to the vault by yourself. And to also call the police if you try to do that. Now, this bank teller is kind of acting like the API. It's the interface between you and the external system, or between you and the bank vault. And you can make a number of requests to this lady. You could, of course, ask her to give you some money, but that obviously is going to involve checking your ID, making sure that you have your account number, and she'll have to do a whole bunch of checks. But you can also go into the bank and ask the bank teller for things that doesn't require any form of authentication. For example, you can say, well, what are your opening hours? And this is the equivalent of making a very, very simple GET request, where you just try to get a piece of data from a website using their API. Now, one of the simplest APIs that I like to introduce students to is the International Space Station Current Location API. This is the endpoint, and you can see that it returns the output in the form of a JSON, which we've already played around with quite a bit. If you want to make a request to this API, you can, of course, use your browser to do it. Just paste the endpoint, which is a URL, into the address bar. And once you hit enter, you can see the result come back in the format of a JSON. And this describes the current ISS position in terms of its longitude and its latitude. If I refresh this, then I will make a new request to this endpoint and I will get a slightly different piece of data back because the ISS is moving actually quite fast through the air. So every time you can see that it's moved by a little bit. Now, if reading the data like this is a bit difficult, I recommend installing a free Chrome browser plugin called JSON Viewer Awesome. And what it will do is whenever it sees JSON data being rendered in the browser, it will display it in a nice tree structure. And it will look something like this. So you can collapse each of these parts and you can see that this is a dictionary effectively with 3 items: timestamp, message, ISS position. And then when you tap into the ISS position, you can get the longitude and latitude. Now we've already seen the JSON data format. And we know that it was originally created for JavaScript, but later became almost the standard way of transferring data across the internet. And the reason for it is really simple. If you take something like a Python dictionary, let's say you have a wardrobe, right? It's kind of like you're going to IKEA, you spotted a wardrobe you would like, but you don't want to carry this home in, its entirety. It might not even fit in your car. Well, what do? Well, in IKEA, at least the way they've solved it, is they sell you a flat pack. So all the pieces flat against each other and you go home and you build it yourself. This is the equivalent of a JSON. It's very minimalist. It doesn't have a lot of spaces and a lot of indents. It just has a couple of symbols to denote which are the keys, which are the values, which are the separate key value pairs. And this can be transported across the internet very, very quickly because of how small and flat it is. Now, once you receive this JSON, then you can reconstitute it back to your original Python dictionary or a JavaScript object, depending on what programming language you're working with. And this is the equivalent of taking your screwdriver and putting together that IKEA furniture. But luckily for you, this process is a lot less painful than putting together IKEA furniture. It's actually super easy. Let me demonstrate. Here I've created a brand new project from scratch, day 33, and inside my main.py, I'm going to try and make a request to the ISS location API. So the first thing I need to do is I need to import a library to help me to do that. And the one that I'm going to import is called requests. And note that there's an S at the end. And this has to be installed because it does not come pre-built with Python. So you can click on it, and then once you see the red light bulb, click on it and get it to install the package called requests. Once that's done, then you'll be able to use it. Now, what we're going to do using this request package is we're going to call one of its methods called get. So this is going to help us get the data that we want from the endpoint. The endpoint goes in an argument called URL, and we have to check the documentation to know what the endpoint is. So in this case, if we want to get hold of the current location, then this is the endpoint URL. So we can simply copy it and paste it in here as a string. Now, once we've gotten the data from this, then it's going to be returned and we can capture it inside a new variable, which we'll call response. So this is going to be equal to the response that we get back from this particular website's API. Now, let's go ahead and print this response. So let's run our project and making sure that you are connected to the internet, because this line of code is going to go across the internet and fetch this data for us. We get back a response. Now we have successfully made our very first API request from within our Python code. However, when we print the response, we don't see the JSON data like we did when we made the request directly inside our browser. Instead, we see this number 200 printed here. That is our response code. And in the next lesson, we'll dive deeper into how to work with these responses and what exactly these response codes mean. So what are the response codes that we can get from an API? Response codes actually have a very specific meaning, but the most important thing they tell us is if our request succeeded or if it failed. Now, if you've been using the internet for a while, you've probably come across the 404 response code. And the 404 response code basically means that the thing that you're looking for doesn't exist. And you can see various websites having fun with this 404 page. Basically, when you're trying to retrieve something from a website and it doesn't actually have the thing you're looking for, then this is the code you get. But there's actually a lot more response codes other than just 404. And in fact, you could summarize these status codes just by looking at the first number. If it is 100 and something, then it's telling you, hold on, something's happening, this is not final. If it's 200 something, then it's saying, here you go, everything was successful, you should be getting the data you expected. If it's 300 something, then it usually means you don't actually have permission to get this thing, so go away. 400 something, it means you screwed up. Either it could be a 404, which means that you screwed up and the thing you're looking for doesn't even exist. Or it could be 500 something, which means I, as in the server that you're making the request to, screwed up, and maybe the server is down, maybe the website is down, or maybe there's some other issue. So that's just a quick at a glance sort of way of remembering what's actually happening when you're getting these response codes. Now, you can actually dig deeper into this response object and you can get a whole bunch of things from it. For example, if you wanted to know the actual status code instead of just a response object, then you can say response.statuscode and you actually only get the status code. But notice how if I change this URL and I make a typo in here, instead of ISS, I have IS, then now I get a 404 as my response status code. Okay, so if we get the status code 200, then it means that we were successful. But what do we do when we get a different status code? What should our program do when the request fails? We might be tempted to write code like this. By checking to see if the response.statuscode is not equal to 200, we can actually figure out, well, this means that there probably was an error. Now, it doesn't really make sense to just print out an error because the user who's using our program might be expecting something to happen. So in most cases, you might want to raise an exception instead. You could say bad response from ISS API. But as we learned from our module on errors and exceptions, this is not very good. Firstly, this is not a very specific exception. It's going to raise a very general type of exception. And secondly, all that we're catching is when the status code is not 200. What if we wanted to know specifically which status code we got back? Well, we could, of course, check, well, if the response status code was equal to, say, 404, then we'll raise a particular type of exception that says that resource does not exist. And then we can have an elif that says, well, if the response status code was 401, then that means that you should raise an exception because this particular code only happens when you are not authorized to access this data. Now, there's a lot of status codes that you could be getting back. And in the course resources, I'll link to this particular web page where it tells you all of the possible codes that you could be getting and what it means. As you can imagine, it's impossible for us to write this many if statements checking for every single possibility. What do we do instead? You can actually do away with all of this by getting the request module to generate the exception instead. The requests module is the most popular way for Python developers to work with APIs. And you can see in their statistics just the number of stars, number of forks. And from these stats, you can see just how much active development there is and how popular this particular module is. Now, if you want to take a look at the documentation, then you get taken to their website and it tells you all of the things that it can do, which is quite a lot, actually. Now, I won't read through all of this with you, but if we take a look at one of the sections, errors and exceptions, you can actually call raise for status on the response you get back in order to raise a HTTP error if the request returned an unsuccessful status code. Basically, instead of us trying to raise an exception for every single possible status code and telling the developer what might be the reason, we can simply use the requests module by saying response.raise for status. So now what you'll see is that if we don't get a 200, which is the pass, let's say I mess up this endpoint again, then you'll see an exception being raised and it's telling us, look, it's a 404 client error. This URL is not found. So this request module is actually really powerful and we're going to see how to use various aspects of it in the upcoming lessons. But for now, the first thing we need to get hold of is the actual data from this particular API. To do that, we tap into our response and we get the JSON data. So this is the actual data. And when I print it, you can see that it looks exactly the same as what we got in our browser. Coming back to our code, we have this JSON. We can tap into it just like we would for any Python dictionary. We could use some square brackets and then type in the name of a key that we're interested in. For example, if this was a Python dictionary and we wanted to know the ISS position, then we would add the square brackets and then pass in ISS underscore position. And now when we print data, you can see it's now narrowed down and drilled into the position to give us this longitude and latitude. So we can go even further and tag on another set of square brackets and try to get hold of, say, the longitude. And now we get that actual piece of data. There you have it. We could get access to the longitude by tapping into our data in the format of a JSON and then getting the ISS position, and inside that dictionary we can get hold of the longitude. And we can do the same thing in order to get hold of the latitude, but we would change the key, of course, to latitude. So now I'm going to create a tuple with the longitude and the latitude. And now if I print it out, you can see how I've managed to nicely format my code and get the pieces of data that I want in order to be able to work with it in my project. Now, if you want to see where that particular latitude and longitude is on the world map, then we can use a tool called latlong.net. So if you go to Geographic Tools and go to Latitude and Longitude to Address, then you can paste in the longitude and latitude values that we got from our API. And when we click Convert, then you'll see on the map it shows where in the world the ISS is right now. So at the moment, it's somewhere to the east of Japan over the Pacific Ocean. And of course, it's telling you no address found because I don't think anybody lives right there. So have a play around with that and make sure that you've fully understood what's happening in these few lines of code and how we used the API endpoint to get the data that was showing up right here. In the next lesson, I've got a challenge for you. Now that you've seen how you can make the most basic type of request to an API endpoint, I want you to build a Kanye quote machine. This is what it's going to look like, and these are real Kanye quotes. So every time you click on this button, which has a Kanye emoji, you can see he'll say different things. And some of the things he says are incredibly deep, and other things are a little bit weird. But we've created the starting file for this, so you don't have to spend a lot of time building up the UI. All I want you to do is to figure out how to use the API, which is at kanye.rest, and this is the API endpoint. So you can test it out, of course, in your browser just by putting it into the URL bar. And you can see you get back a very simple JSON with just one key and one value. And every time you run it, it'll give you a random quote. Head over to the course resources and download the Kanye quotes starting file. And once you've unzipped it and open it up, you can see that there's the background image, the Kanye PNG, and there's all of the existing code that's required to generate this user interface in tkinter. The point here is I know you can make tkinter apps, but I want you to use the request module that you learned about just now in order to get this function to work, so that every time the Kanye button, this one, is pressed, then we trigger this get quote function, and this is going to fetch the quote from the Kanye API here and fill it into this quote text on the canvas. Using what you've learned before, I think you can do this pretty quickly. So pause the video now and give it a go. All right, so to begin, we of course need to import our very important requests module, and you need to install it if you see some red squiggly lines. But if you see it grayed out like this, then it means that we've already installed it into the starting files. Now, once we've got hold of that module, then we can write some code here so that we get our function to work. Now, what should happen when the user presses on the Kanye button? Well, we have to fetch a new quote from the API. This is the API endpoint, And we're going to use the request module to make a request and get some data from this API. So this is a code that we used before to figure out where the ISS was, and we're going to save this as the response. Now, once we've got our response, we're going to call response.raise for status so that if we don't get a 200, which is everything is a-okay, then we want to actually raise an exception. Now, the next thing I'm going to do is I'm going to get my response to show me the JSON data. And I'm going to save that as the data. And then if we take a look at what the response looks like, then you can see it's just a single key value pair, and the key is quote and the value is the random quote. So we can get hold of the actual quote by simply tapping to our data and then using square brackets to fetch the value under the key quote. And once we've got that piece of text, then we want to put it into our quote text, which is on our canvas. And as you saw before, the way we do this is we say canvas.itemConfig, and the item we want to configure is of course our quote text, and the thing that we want to configure about it is its text, and we're going to set it to equal this quote that we fetched just now. So now if I run my code, you can see my Kanye Says app showing up, and this is where the Kanye quote is going to go. So if I click on Kanye, you can see it shows all of his quotes. So did you manage to get that? If not, be sure to head back to the last lesson and take a closer look at how we formatted our request and our response. We've seen how APIs can have endpoints, and we said that's equivalent to the address of the place that you want to get some data from or you want to communicate with. But APIs also have something called parameters. And this is a way that allows you to give an input when you're making your API request so that you can get different pieces of data back, depending on your input, in the same way that we've given different inputs into the same function in order to get a different outcome. Coming back to our bank analogy, that's kind of similar to going to the bank and instead of just asking them for, well, what are your opening hours, a sort of broad stroke question, you can also pass in a parameter. For example, you could say, well, what time do you close on Monday? Or what time do you close on Tuesday? And this allows you to get the specific piece of information that you're interested in, depending on the input that you provided as a parameter. Now, not all APIs have parameters. Some are incredibly simple, like the ISS location API, but other ones allow you to provide parameters. And this is a sunrise and sunset API that gives you the time when the sun is going to rise and set wherever you may be. So you have to obviously provide a location so that they can tell you when the sun is going to rise and set at your position. We can do that through two parameters, the latitude and the longitude. And you'll notice that in the API documentation, they will usually tell you how you should structure your parameter. So for example, here the latitude can be specified using a lat key, and the longitude is LNG as the longitude. And they want those pieces of input as floating point numbers. Now, you also see that some parameters are required and others are optional. Just as we can have optional and required parameters when we create functions, you have the same thing in APIs. The optional ones all have a default value. For example, the date you could provide, say you wanted to know the sunrise and sunset on a particular day in the future or in the past, but you can also leave it empty and it will default to the current date. Now, the endpoint in this case is this particular URL, api.sunrise-sunset.org/JSON, but don't worry, I'll also link to this documentation in the course resources as well. Let's see how we can get this to work. I'm going to comment out all of the things that were related to our ISS location. And I'm going to use this requests module in order to get the sunrise and sunset times, because this is going to be really important when we're creating our final project, because it's almost impossible to spot the ISS in the sky unless it's actually dark. So we need to know when the sun's going to go down and when the sun's going to come back up in order for us to know if the sky is actually dark enough for us to be able to spot the ISS traveling in the sky. Let's go ahead and set up another response, which is going to be set up to a request. And this request is going to get some information from this particular endpoint. So let's copy that over and make sure that you leave out this final full stop. That's just a part of the sentence and not a part of the API endpoint. So it should look something like this. And then we're going to get our response to raise an exception if there was an error status code, so anything other than 200 basically. Now, if I run this as it is, you can see I already get an exception. And the exception is a 400, which, if you remember, means bad request. This server cannot or will not process requests because of something that they think is your fault. In our case, the thing that we've done badly is we haven't provided the required parameters. So how is it supposed to tell us the sunrise and sunset times if we don't tell it our location? Let's fix this. Let's create a set of parameters. And you can do this by simply creating a Python dictionary. Now, the keys for the parameters must match the ones specified in the API documentation. So it's lat for latitude and lng for longitude. So let's create those keys as strings, and then we can provide our latitude and our longitude. So how do we know what is our latitude and longitude? Well, we've got our good old friend latlong.net. So here I can type a particular place name. So right now I'm in London, and if I click find, it'll find me on the map and it will tell me what is my latitude and what is my longitude. So let's copy these over and let's create them as constants. So I'm going to have a mylat, which is equal to this as a floating point number, and then my longitude. Remember to include any negative signs if you see it. That's actually a part of the latitude longitude encoding. So now I can set my lat key to the constant mylat and the longitude key to the constant mylong. So these are the values that I got from my latlong.net search, and then I formatted all of this into a dictionary using the keys that were specified in the API documentation here. Those are the only two required parameters. So if we now add this in to our GET request under the argument called params, then we're now able to run this request again, and you'll see that this time we don't get any exceptions. So we can assume that everything went swimmingly. The data that we get back is under the response.json. So let's go ahead and print out that data and see what we managed to get. We got a JSON as usual, and the JSON contains the sunrise time and the sunset time, in addition to other things like when is the solar noon, how long is the day, what is the day length, and so on and so forth. So you can see this one is a lot longer than what we had before. Now, the two pieces of information that we're interested in is just the sunrise and sunset times. If we want to view this JSON data in a nicely formatted way, then we can do that by putting the full request into the browser URL bar. And the way that you format parameters in a URL string looks something like this. In the sample request, they've shown you that this part is the endpoint URL, and then afterwards you can add a question mark to denote that you're going to add some parameters. And then you add each parameter with the key, equal sign, and then the value, and then you can tag on more parameters with the ampersand or the and symbol. So let's try putting this into our browser bar. So here's the latitude, which we'll paste in here, And here's the longitude, which we'll paste in here. So now let's hit enter, and you can see that our JSON Awesome viewer, which we installed at the beginning of today's lessons, is now active, and it's showing us all of this data in a much nicer format. So we can see that this sunrise time that we're interested is the value for the key sunrise, which is then inside another key called results. So we can use these two keys to pull out these specific pieces of data that we're interested in. So we can get the sunrise, which is equal to data, and then square brackets, we put in the first key, which is results with an S, and then we can add the next key, which is sunrise. And we can do the same thing for the sunset time. And now if we print out our sunrise or our sunset time, you can see it's actually the exact piece of information that we're interested in. Notice how this data is formatted, and it's giving us the time in a 12-hour format. So it's going to have AM or PM tagged on at the end. Now, what we want to do is we want to be able to get the current time. So we can use the datetime module. From the datetime module, we'll import the datetime class, and then we can get the time now by tapping into that class and then calling the now method. But you'll notice that the format of time now is very different from our sunrise and sunset time. Our sunrise and sunset time are in the 12-hour format, whereas the time that we're getting back from datetime is in a 24-hour clock format. So how can we change this data that we're getting back from the sunrise and sunset API? Well, back to the API we go. Notice in one of the parameters, there is a parameter called formatted, which is an optional parameter, but it can be turned off or on. On is by default, which means it's going to format it in a particular way with the 12-hour clock. But if you switch off the formatting, then it will give you the Unix time in this particular format. And this will be a 24-hour clock. So here's your challenge. Go ahead and change the parameters that you have and make sure that the data that we get back is not formatted, so it's set to 0. Pause the video and complete this challenge. All right, all we have to do is to add one more parameter to this dictionary, and the parameter must have a key that matches the one specified in the documentation. So I'm just going to copy that over, and then we're going to set this to 0 for off. So now if we rerun our code, you can see the data we're getting back is now in Unix time, which is a 12-hour format time. So currently where I am in London, the sunrise time is actually quite early. It's at 4 o'clock in the morning. So notice how the first part is the date, and then we have a T, and then after that we've got the time. What we want to be able to do is to compare this part from our sunrise sunset API against this part from our date time API. So how can we just isolate the hour number from each of these? Well, we can use a Python method called split. And you've seen this before. Basically, you have to provide a separator, and it will split a string by that separator, creating a list. So if you click on this, try this yourself, you can see that this string becomes this list by splitting that string with the # separator. Now, in our case, the separator that we want to separate by is firstly to split it by this T, which is going to give us this part as the first item in the list and this part as the second item in the list. And then we can take the second part and then split it by the colon. And then we can get this first part of the list. So here's how we would do it. So we can say sunrise.split, and then the separator we want to use was that capital T. now if I hit print, you can see we've got a list that is now separated with two things on either side of the T. So let me just comment out the time now, and we've got the sunrise and the sunrise split next to each other. So that T is removed and the two things on either side have become two items in our list. Now we want to split this part further. We can get this item by tapping into the item at index 1, so 0, 1, and then we can split this even further by tagging on another split function. Here we can split it by the colon. So let's go ahead and provide that as the input. And now you can see the result we get back is this. We've split the part that comes after the T by the colon, and we've got 04, 03, 32 plus 00, and then 00. This is clearly the item we want, so all we have to do is just to add a 0 at the end. And now we've got the actual hour in the 24-hour clock formatted from our sunrise time. You could, in fact, just simply take all of this part after the sunrise and tag it onto the end of this line and also this line so that we actually get the sunrise and sunset times in terms of the 24-hour clock, like this. Now we're perfectly poised to start comparing it against the time that we're getting right now. So we can take our time now and tap into the actual hour, and you can see now we've got our sunrise, which is this first number, sunset, which is the second number, and the third number is the current clock time in terms of the 24-hour clock. So in order to figure out whether if it is day or night, all we have to do is compare this number against these other two. Now in the next lesson, we're going to finish off this project and put everything together in order to get an email when the ISS is passing overhead and it's currently nighttime. So for all of that and more, I'll see you there. All right, congratulations on reaching the final project for the day. Head on over to the course resources and download the starting files for the ISS Overhead Notifier project. If you followed along with all the lessons today, then you've seen how we can get data from a particular API by simply just providing an endpoint. So this is the simplest type of API calls. And then you saw how we could pass along with the API call a set of parameters in the form of a Python dictionary in order to get a specific piece of data that we want based on the parameters that we pass over. So in this case, it was the sunrise and sunset time of our local area. Now later on, I showed you how we can split the string that we get back from the sunrise and sunset times in order to get the particular numbers that we're interested in, which is the time of the sunrise and sunset in the 24-hour clock format. Now it's time to put all of this together. If the ISS is close to my current position and it's currently dark, so basically it's nighttime, then send me an email to tell me to look up. That's the objective of the challenge. However, as a bonus challenge, see if you can further modify the code so that it runs every 60 seconds if the ISS is overhead. These are the three things that we need to achieve. And just as a quick tip before you get started, remember that the sunrise and sunset times are both in the format of strings. So if you want to be able to work with them to compare to time now, you also have to change this to an integer. Now, the second tip I've got is that the ISS position, the longitude and latitude that you get back, will be decimal numbers, but it's currently in the format of a string. So you'll need to convert that into a floating point number if you want to compare it against your current position. Now, when we're checking whether if the ISS is overhead, we want to have a margin of error. It doesn't have to be right above me, precise to this number of decimal points. It can be plus or minus 5. So if the ISS's latitude was anywhere between, say, 56 and 51 minus 5, which is 46, then that's perfectly fine. That means I'll still be able to see it. take a look and find your own latitude and your own longitude and see if you can figure out how to compare that against the ISS's latitude and longitude and adding in that degree of error. In fact, consider creating a function that returns true if your position is within +5 or -5 degrees of the ISS position and false otherwise. So you should now have all the capabilities to complete this challenge. Pause the video, give that a little bit of a think, and see if you can complete the challenge. All right, what we want to do up here is we want to compare the ISS's position against our position. Now, what we want to check is to see if our position is within plus or -5 degrees of the ISS position. So let's take one part of that position, the ISS's latitude, and we want to check to see if it is close to my latitude. If my latitude is currently 51, then 51 minus 5 would be 46. So we can check to see if 46 is less than or equal to the ISS latitude, and then if the ISS latitude is less than or equal to 51 plus 5, which is 56, then if this is true, it means that this value is in between these two values. So let's replace these numbers with my actual latitude. So my lat minus 5 and then my lat plus 5. And then we have to make sure that it's also true for the longitude. So we're going to do basically the same thing, but this time using my longitude. So my longitude minus 5 is less than or equal to the ISS's longitude, and the ISS longitude should be less than or equal to my longitude plus 5. If both of these things are true, then my position is pretty much within plus or minus 5 degrees of the ISS. At this point, I should probably create some sort of a function for this. So I could say, is ISS overhead? And I can indent all of this into that function. And if this happens to be true, I'm going to return true. This part deals with checking whether if the ISS is at a similar position to my position. The next part deals with figuring out whether if it's nighttime or not. So again, let's create a function, and I'll call it isNight. And this function is going to return true when it is actually nighttime. In order to figure out whether if it is nighttime, then we're going to get a response, so there's a typo there, from our request to the Sunrise Sunset API, passing in all of these parameters which contain my current location. And then from the data we get back, we figure out the sunrise and sunset time by formatting that string and then turning it into an integer, which is going to represent the current hour in the 24-hour time format. So then we figure out, well, what is the current time using the datetime module, and we can check to see, well, if the time now is greater than or equal to the sunset time, or if the time now is less than or equal to the sunrise time, then it means it's dark. So now we're getting a warning telling us that this time now is a datetime object, but this sunset and sunrise are whole numbers or integers. So what's happened? Well, datetime now is in fact the current date and time, but what we actually want is the current hour, and that converts it into an integer, making this comparison valid. So if it is currently nighttime, then we're going to return true, and if the ISS is overhead, then we're also going to return true. So now we've done these two parts. All that's left to do is, once both of these things are true, we can send ourselves an email to tell us to look up. So if the ISS is overhead and it is currently nighttime, then we're going to initiate our email sending, which is going to require our SMTP lib. And I'm also going to add my email and password as constants up here. And now we can create our connection. And I'm using, again, a Gmail server. So it's going to be smtp@gmail.com. So we went through all of this when we talked about email in detail. So I won't waste time talking about it again. I'm going to send this email from my own address and also to my own address because, after all, I'm just making a notification for myself. And the message in this case is going to have the subject line of look up, and I can even add an emoji here. And then the content is going to say the ISS is above you in the sky. That's it. That's all there is to this. Now, it'll be quite hard to test this code because we have to wait for the perfect condition before all of these things will actually be true. While this is the end of the challenge for you, there's one thing I want to change with this code to make it a little bit better. We can actually put this if statement inside a while loop. So we could say while true, which means this loop is going to go again and again and again, checking if the ISS is overhead and it's at night. Now, this is going to happen quite frequently because it's in a while loop, but we can slow it down by using the time module. So we could import the time module and then say time.sleep, and we can get it to sleep for 60 seconds or however much long you want to wait between running this script. So now if you hit run, you won't see that final code where it tells you that your program is done running. It's actually continuously running in the background, and it's going to execute this code every 60 seconds. So as long as you have your computer on and this is running, then you can run this for a whole 24 hours. And I bet you at some point in the night, you'll get 2 or 3 emails telling you that the ISS is overhead. So all you have to monitor is just to switch your notifications on your phone, and when that email comes in, to look up into the sky. So I hope you enjoyed building this project with me, and I hope that you're going to be able to spot the ISS tonight. If you do, take a video and let us know what it looks like.